want to work here, but you do. Behind the marbled walls and grandeur that is the public face of the legislative building lurks a far more sinister scene. Corrosive salt leaching from the sandstone exterior. A main shutoff valve that's inaccessible, lodged between two pipes. A rat's nest of wiring, much of it unlabeled. A ventilation tunnel that runs along the perimeter of the building, jammed with pipes and wires. Airflow at 70% of what it should be. A fire here would be hard to get to, while smoke would flow through the vents and fill the building. Walls, added later for strength, encase the plumbing in concrete. Leaks can take a week to track down and a bundle to repair. And of course, there's the damage left behind by the Nisqually quake. What goes on behind the scenes is hard to believe when you look at this beautiful, imposing structure, the most significant building in our state. But these are its ugly secrets, some little, some big, and some dangerous. The Legislative Rehabilitation Project exists to fix them.
In the years since this building was constructed, the state has grown considerably. That growth has also impacted the use of this building. In addition to the growth in the staff from 155 to 455 people, thousands of people have come to visit this building, both as school children, tourists, and the general public looking to see how their state government is working. Oftentimes this building is stressed by that load, washrooms are overcrowded, air quality gets impaired, and general use has taken its toll on this building. We're down in the garage looking at some of the ways we've had to upgrade technology. When this building was originally built, only 75 telephone lines were installed to accommodate the needs of the legislature. Since that time, thousands of telephone lines have been installed to accommodate telephone needs, fax machines, and computer needs. As part of our rehabilitation project, we're going to be relocating these lines and upgrading them and allowing for expansion for future. These telephone lines are also going to be augmented with fiber optics to upgrade speed and quality. We're here in one of the restrooms on the first floor, and we wanted to take this time to show you the kinds of problems we're facing with some of the systems in the building. We have piping here that's mounted on the surface. We've had to do this because we've not been able to repair the pipes that are in the walls. When we've had prior earthquakes, or just because of the age of the pipe, all of a sudden we experience water coming out of the walls. We haven't been able to get to the pipes because we have gone through in past years and filled these walls with concrete to strengthen them. When we've put those concrete in the walls, we've just buried all the pipes, can't get to them now, so we've had to do things like this, actually mount the pipes on the surface. These pipes that are mounted here really represent the symptoms of the problems we're trying to cure with this rehabilitation project. These walls have buried in them vents, wires, piping, all of which is inaccessible. As the years go by and they start to wear more and more, we need to be able to get access to them or to update them as technologies change. As part of the rehabilitation project, we're going to be relocating all of these systems and giving them a way to get to them to gain accessibility so that we can do the repairs and maintenance and upgrades that are needed for the tenants of this building.
There's examples of leaks throughout the building here, and this is just one of the examples that I'm going to show you. This particular leak generates all the way from the top of the cupola and also the 5th floor drain level. And what it does, it follows the drain pipe all the way down until it reaches the garage level, and actually it comes down to this point here and drips and just flows right here, and you can see the salt content on the floor here where the outline is of the water path. We have capped 2 drain lines and we still have the problem.
Tunnels run the perimeter of the building. Designed originally for ventilation, they are now crammed with pipes and wiring. Then there are the 5th floor catwalks.
The piping up here is pretty big. It's a very sturdy vent system that was installed when the building was constructed back in the 20s. It is, however, insufficient for the current needs. When this building was built, it was designed to hold 155 people. Currently, it holds 455 people, 3 times the amount it was originally designed for. The other problems that we have is a lot of this piping was used to provide routes for subsequent additions of telephone, computer lines, communication systems that weren't originally envisioned when the building was built. Therefore, we have several problems. We have more people breathing the air, and reduced airflow to the tune of about 30% creates real problems with air quality. In an effort to try to improve the air movement in this building, we've tried to increase the amount of air. This has resulted in having this negative pressure situation. The air that's being discharged down here in the garage is actually being funneled back up into this doorway. As the door opens, it presents several difficulties. The door is hard to open up, there's a tremendous amount of air blowing on people coming through, and we're stuck with a door that doesn't really close. People actually coming through this door have to pull it to close it. In an effort to balance the situation, we're going to be changing how this air is vented as part of the rehabilitation project. I'm standing on the service ramp behind the cafeteria on the first floor. This ramp was originally built when the building was constructed in 1927 to provide service from the garage level to the cafeteria. This ramp then continues up from the cafeteria to the first floor. Though this ramp was probably very useful in its day, it does represent a danger to all folks, including women with high heels, when they come onto this surface. If this area is wet or has some slush from snow covering, it can provide a very real fall hazard. As part of the rehabilitation project, we're going to be filling in this ramped area. We're going to be connecting the first floors on both the west side and the east side and providing a level surface. We must point out that this is an historic feature of the building. So the work that we're going to be doing here is reversible. That way, at some future time, if people decide they want to restore this feature, we can do it. On this first floor, we're going to be removing most of the walls to provide for reconfiguration. That reconfiguration will provide more public space and better access to utilities. We're also going to be reconfiguring the exits. People in the hallways are going to be able to see light. They'll have a more intuitive direction. In the event of an emergency, they can get out quicker.
Money to rehabilitate the legislative building comes from two sources: the Capitol Campus Land Trust, that's about 90%, and tenant rent for the rest. Let's talk about the first of those, the Capitol Campus Land Trust. It was established in 1889 when Washington became a state. Public lands were set aside specifically to build and maintain our state capitol campus. Most of this is forest land. Revenue from the sale of timber was used to build the legislative building in the 1920s. Those lands were replanted with trees that are now 75 years old, mature and ready to harvest for the renovation work we need to do. The revenue from this Capitol Campus Trust, in other words, from these harvested trees, will repay general obligation bonds. I want to emphasize this revenue cannot be used for any other purpose. It's also important to note that no general fund tax revenues will be needed to pay for this work. Our state's creators wisely saw the need for money to maintain and refurbish our Capitol. That's why we have this dedicated fund to pay for the work we sorely need to do today. I'd like to say a hearty thanks to all the staff, elected officials, and others who developed, reviewed, and approved the financing plan for our current project. This plan was the work of a subcommittee of the Legislative Building, Preservation, and Renovation Commission. It included members from both the House and Senate and was chaired by the State Treasurer.
This project will also have some economic benefit to the citizens of the state of Washington. For every dollar spent, $2.25 of economic activity will accrue. For every $1 million spent in this project, 30 new jobs will be created. We're facing some special challenges in the state reception room. The marble columns wobbled during the Nisqually earthquake, and we have to find a way of attaching them at the top. We also experienced some damage to the skylight. Once these repairs are made, the room will be safe to use again. We're approximately 100 feet above the rotunda floor, and the area that we're looking at is the interior columns. These columns look like marble from the ground, however they are in fact plaster. During the earthquake, Nisqually earthquake, we had some difficulties up here where the dome and the columns were moving in different directions. So the dome was rolling, much like a coin would roll on a tabletop, and as it did, it created a zero gravity effect right underneath the dome. When that occurred, there was movement up here, and the dome lifted the steel structure, creating breaks in the dome walls and in these columns. Every one of the columns up here have cracks shown around the base. There's also cracks at the top of these columns.
A cutaway revealed the columns are all structurally sound, but cracked plaster could fall to the rotunda floor. The drum, the area containing these interior and exterior columns, took a hit in the quake.
And some of that damage has been reflected in the masonry that we could see within these areas that we call catacombs. What's evident with these brickworks is a displacement. Part of the bricks stayed stable and the other part actually moved. So this drum that we're standing here actually rotated about 1/4 of an inch to 3/4 of an inch and compressed at the same time. Part of the urgency of the repairs that we're proposing as part of the rehabilitation project is to stabilize this area. It will require additional shear walls, such as the ones that we've placed here. It'll be located at a right angle to this drum, and we're also going to be connecting all of the structure with the main building down below, and that'll keep that building from acting independently with the drum up above. We've put these crack gauges on these walls to give us a good measurement of any kind of movement that gives us an opportunity to see if the building has sagged or if there's another event, and if that event occurs, how much the building moves.
As you know, the building was damaged both in 1949, 1965, and by the 2001 Nisqually earthquake. The state chose at those times to go forward with voluntary seismic upgrades and repairs to the building, which paid great benefits when we had the February 28th earthquake. Those earthquakes, though, are not near as large as the earthquakes that we predict can happen. The earthquake that we are trying to design this building for, or attempting to design the building for, is roughly 50% greater than the earthquake that we experienced in February. The upgrades that we have planned for the building are strictly designed to bring the building into life safety conformance. We are not trying to make the building the only building standing in Olympia. We are strictly trying to prevent anyone from being killed or seriously injured in the building during an earthquake. The work is going to be done in conjunction with a lot of other work in the building, both dealing with architectural program issues, mechanical system upgrades, electrical system upgrades, and it's very important that we do all of this work simultaneously because all of this work involves the removal of historic finishes. And we only want to remove those finishes once. If we have to remove them multiple times, that's going to lead to greater cost. And so we see quite a bit of cost efficiency by us going forward here in a timely manner and doing all this work simultaneously.
The opportunity to do this project is now. We have many needs. We have to take care of the safety, we have to take care of the maintenance issues, and we also have to take care of repairs. So not only can we do the repairs that are associated with the earthquake, aided by FEMA money, but also apply the money that's been authorized by the legislature.
A separate effort would fund beautification, education, and historic restoration on this living document.
I'm a member of the private financing committee that's working with general administration to see if the public would provide money from their sources to help with this building. We're out interviewing 100 people, individuals and foundations across the state, to see if they would provide private financing for the extras going into this building, for furnishings and public education components. We expect to have a report by the end of the year, and I believe that the public will step forward to help finance the finishing of this public treasure, our Capitol.
Having worked in this project for the last year, I've really come to appreciate the pride and ownership that's attached to this structure. This building has been a real gem in the state assets, and it's our responsibility as the stewards of the state government to pay attention to the utilities, to the structure, and the historic aspects. We need to act now to make sure that this building is here for future generations.